Okay, let's start para matapos tayo agad. Good afternoon. Our lesson for today is the continuation of our last module, module 3, last Friday. Okay. I-share screen. Okay. So, let's begin dun sa module, isang module within the chapter title, Data Access. Okay, so data access, addresses, so addresses, both data link and network address layers use addressing to deliver data from source to destination. So we have two layers that use addressing to deliver the data that passes through them from the source to the destination. Okay, so anong layer siya? That would be data link and the network access layer. Okay. So network layer source and destination address responsible for delivering the IP packet from the original source to the final destination. So network layer, okay, so a network layer source and destination address is responsible for delivering what? The IP packet. So that's the term na you have to remember. Pag network layer, ang dinideliver nila ay IP packet. Okay, so the next is data link layer, source and destination address din. Responsible for delivering what? Data link frame naman. Okay, so data link frame. So when we say data link layer, they deliver the data link frame. So they have their own PDU. Yan yung kanilang protocol data unit. So last time na na-discuss natin is their protocol data unit. Kapag network layer, that would be packets, and then from data link layer, that would be yung frame. So makikita natin dito on our diagram. So on layer 1, which is our physical, timing, and synchronization bits. So this would be yung ating 1 and 0, or on and off. On and off. Okay. Then the data link layer, ito na yung sabi natin, data link, source, and destination. This would be ang ating layer 2. This would be the destination and source ng physical addresses. When we say physical addresses, this would be yung ating MAC addresses. Physical, permanent, unique. And then, ang kanilang PDU ay frame. Pagdating sa data link. Dito naman sa network layer, or yung ating ay makuha yung aking eraser. Okay, sorry, ay makuha yung eraser. There's a network layer, source and destination address, meron din siya. That would be the logical network address. Okay, this would be yung ating mga IP address, sabi nila. IP wala dito nakalagay. IP address or the logical network address. And ang PDU natin dito would be, sinasabi natin, IP packets. Okay, packets. Yan. So sa isang upper layer, we also have an addressing. But this time, they are called ports. Doon sa transport layer. Which is a transport layer, ang ating PDU or protocol data unit ay yung ating segment. So when it comes to sa ating transport layer, nilalagay niya doon kung anong port number, yung source and destination. Okay, for example, yung ating browser, yung ating HTTP that runs on port 80. Okay, so ang browser natin, kakausapin ang isang server o web server. Web server, meron server. Okay, papadala niya yung kanyang segment, lalagay niya ng port number. So that would be port 80. Pagbigay niya kay network layer, lalagyan ni network layer ng IP address. Si IP address ng source, for example, ang source natin from the upper layers, ito yung ating tatlong layer na upper layers like session, presentation, and the application layer. Yan. Ang protocol data unit natin dito is data, di ba? Data stream. So from the user, and then ginawang HTML, then nag-open ng session, and then pagdating sa browser, bababa na siya sa network para mai-transfer na kasi dito sa upper layers, processing pa lang. Pagdating dito sa segment, dito na this is where segmenting or sequencing, and yung chopping into smaller parts. And then yung browser, pag gumamit siya, pag gusto niya ng HTML or kausap niya web server, lalagyan niya ng port. Yung port, lalagyan, pag binigay ni transport layer kay network, lalagyan niya ng IP address. Pagdating kay network layer, bibigyan niya kay data link, lalagyan ulit niya ng address, MAC address. Ito yung source and destination. Ito yung mga network interface card address, yung ating NIC or yung ating MAC address. And then pag naging frame na siya, gagawin na yan ni physical layer ng ones and zero or on and off or kung ano man na Wi-Fi signal ang ating i-encode niya. Okay? Then layer 3 logical address. The IP packet contains two. Okay? Contains two IP addresses, two parts. Okay, the two. That would be yung IP packets natin is yung ating source and IP address and the destination. So the IP address of sending device, original packet, source of the packet, and then the destination IP address, the address of the receiving device, final destination of the packet. So ibig sabihin, if it is outside ng ating network, lalabas siya ng router. If it is inside our local area network, ibablock na siya ni router at nasa loob lang yung destination. So these addresses may be on the same link or local or remote or wide area network. Okay. So ang ating diagram, this is the source IP and the final destination is the web server. Okay, so ang nakalagay dito ay 192.168.1.10. Ang ating IP address ng web server is 172.16.1.99. That would be outside our local network. So that would be remote. Okay? So that would be remote. Kailangan tawagin si router. So IP packet, then pass kay router, IP packet, then bababa kay layer 3, IP packet ulit. And then the final destination. Okay. Continuation IP address contains two parts. Okay. So yung isa yung network portion or for IPv4 or prefix for IPv6. The leftmost part of the address indicates the network group which the IP address is a member. Each LAN or WAN will have the same network portion. So, kung nasa local ka, you have the same network portion. Host portion, IPv4 or the interface ID for IPv6. Okay, so later on, ma-distinguish natin between what is IPv4 and IPv6. But this time, kasi ang kailangan nyo lang ma-remember is there is an IPv6 address and an IPv4 address. So pag sa IPv4, merong network portion and then merong host portion. Pag IPv6, merong prefix, and then merong interface ID. Yan ang bumubuo ng kanilang IP address. So the remaining part of the address identifies a specific device within the group. This portion is unique for each device on the network. So just like sa inyo, di ba? Just like sa inyo, meron kayong section. Yung section nyo, hindi nagbabago yon. Pero yung ID number nyo, nagbabago yon. Okay? Pero you have the same section. Ibig sabihin, you have the same network portion. And then yung host portion, yung ID number ninyo ay iba-iba. Okay? So unique bawat isa. So just like yung ating diagram using IPv4 only, this is a 32-bit 4 octets. Okay? Kasi IPv6 is 128-bit hexadecimal numbers. This is base 16, this is base 2. Devices on the same network. When devices are on the same network, the source and destination will have the same number in the network portion of the address. So PC1, pag si PC1 daw is merong IP address na 192.168.1.110. And then yung kanyang final destination is the FTP server that has an IP address of 192.168.1.9. So, pag tiningnan natin, the network portion ng ating source is 192.168.1 at ang ating final destination is 192.168.1. Since they are the same, so makikita natin sa diagram, logically, ayan pala silang dalawa. Nasa loob lang ng local network. Okay, nasa loob lang sila ng local network. Actually, kasama yung port na yan. Yan. So, hindi na siya tatawid ng ating router. It will be behind our router. Kasi they have the same. They have the same network portion. Okay? So, makikita natin sa ating packet, sa ating datagram. Okay, so ayan. Meron tayong layer 2 address or data link, Ethernet frame, header, and then meron tayong network layer or the IP packet header. So, ang ating source IP address is 192.168.110. Ang ating destination is 192.168.1.9. So, ang network portion and ang network portion and destination is the same. So, hindi na siya lalabas ng router. And then, pagkatapos yon, tatawid lang siya ng switch. Okay? Because do sa switch, alam ni switch kung nasaan itong mga to. Nasaan yung mga MAC address na yan. Kasi si switch ay meron tinatawag na CAM table. Okay? Later on, malalaman natin yung CAM table or Content Addressable Memory Table which stores the MAC address and its corresponding IP address. Okay. So, tutumbas na yan. Okay, so nung nakita niya, pareho silang network, titingnan na ngayon ni switch, nasaan, MAC address, hindi pala. MAC address, port number. Pala. Port number. Switch port number. Ayan. MAC address, switch port number. Okay? So that would be, kaya nalalaman niya kung saan port yung, saan niya dadalhin. Saan yung ingress port, at saka yung lalabas na port. Kunyari, ito ang ingress. Siyempre, ang egress. Ito. So, egress port dito sa 192.168.1.9. Okay, so yun na. Bakit? Kasi nakalagay yan sa CAM table, or this is sort of a database ng or directory ng switch kung anong port at kung anong MAC address ang katumbas. Kaya pag pumasok sa isa, alam na niya kung saan niya palalabasin. Okay, may iwasan yung ating collision. So hindi niya ipadadaan sa ibang port kasi alam niya. Bakit? Kasi meron siyang table. Role of data link, layer address, same IP network. So when devices are on the same Ethernet network, the data link frame will use the actual MAC address of the destination NIC or network interface card. So MAC addresses are physically embedded. So MAC address, sabi natin, physically embedded. So they are physically embedded. So they are permanent. Permanent. Pag sinabi natin permanent, physically embedded. Permanent, there is no changing, there is no rewriting into the Ethernet network interface card dun sa LAN card natin and our local addressing. Okay. So the source MAC address will be that of the originator of the link, and the destination MAC address will be always on the same link as the source even if the ultimate destination is remote. So, kunyari, kanina, ito, yung magkaibang network, yung sample natin na PC and then user and then yung web browser, magkaiba ang destination or magkaibang network. Pag sinabi niya, lalabas ng router yon, yung NIC nito at saka NIC nito, yun ang source. Ito yung source, ang destination niya ito. So, local pa rin, di ba? Even if the destination is remote. Kahit na ang pupuntahan niya kanina ay dito, ang nag-usap lang, ipapasa niya dito din. Ngayon, dahil they are the same network, the same IP network, hindi na siya lalabas kay router, titingnan na lang ni switch ang kanyang CAM table at makikita niya dyan anong port niya palalabasin. Okay. So, yung all C and all A, yun ang kanyang source and destination MAC addresses. Okay. Devices on a remote network, what happens when the actual ultimate destination is not on the same LAN? Ito yung sample natin kanina, di ba? What happens when PC1 tries to reach the web server? Does this impact the network and data link layers? So makikita natin dito ang destination natin is not on the same network. Kanina FTP ang in-access natin. Ito 'yon. So we have FTP server, we are on the same network. But this time we are accessing a web server outside of our network. Dadaan ng internet or ng cloud. Ito yung cloud. Okay. Usually ang cloud, yan sabi natin, ang web yung cloud. Cloud. Yan, cloud. So dadaan siya ng maraming routers, maraming hop. Okay, so even though, sabi niya, even though na ang source and destination IP packet header contains IP addresses with different network, ang ating data link Ethernet frame always talks within the same network. So ibig sabihin, kung siya PC1, pupunta talaga siya dito sa web server. Yun ang nakalagay sa ating network layer. Pero ang nakalagay sa ating data link layer, yun lang katabi. Okay, so pagdating niya dito, si PC1, ang destination niya is si router 1. Okay, so dito lang muna siya. Okay, pagtingin ni device, na ang aking source ay 192.168.1.110 at ang aking destination is 172.16.1.99. They have different network. So, call natin si router. So, si router ang lalaman sa destination MAC. Okay. Si PC1 ang lalaman sa source MAC. Kaya sabi niya, even though na nasa labas ng network natin. Hindi siya pwede magpadala agad dun sa web server na MAC address. Dito ka muna kay router. Okay, host to host. Okay. Next is when the source and destination have a different network portion, this means they are on different network, just like 192.168.1.1 and 172.16.1. Okay, so yun ang sabi natin kanina, they have different network. Then when the final destination is remote, layer 3 will provide layer 2 with the local default gateway IP address, also known as the router address. Kaya nga meron tayo kanina na dati na meron tayong IP address sa ating setting ng assigning ng address, then subnet mask, then default gateway, and then the ating DNS. Okay, so ito yon. Kasi nung chinek niya, magkaiba sila ng network portion, sabi niya, ipasa natin kay default gateway. So the default gateway is the router interface. Okay, ang default gateway, ito yun. Okay, yung port niya, yung IP address ng port na yan, that is part of the LAN and will be the door or gateway to all other remote locations. So ang default gateway talaga yan, IP address yan ng router. Yun ang default gateway palagi. Okay? Ang default gateway is the IP address of the router. Okay? Nearest to you. Okay? Nearest to you. Okay? Nearest to you. Kasi dalawa yung port niyan eh. Okay? Itong port dito is a member ng port ng network dito. Itong port dito is a member ng network dito. Okay, so ito isang network yan, another network, and then another network. Okay, so dapat kasi itong R1, tatalon muna dito. Kung ito si R3, by our example, dapat ito si R1, tatalon muna kay R3 and then R2. Okay, unless na meron itong connection pa ganyan. Ganyan. So, nag-R1, then R2. Okay, so alisin na lang natin yan. Ano pa? Yan. So, sabihin natin may connection sila pag ganun. Kasi si R1 daw tumalon kay R2. So, ganyan may connection. Okay, so all devices on the LAN must be told about this address on their traffic or their traffic will be confined only to the LAN. Okay, pag wala tayong default gateway, there is no way tayo makalabas ng ating local area network kasi wala tayong default gateway. Si router lang ang marunong makipag-usap sa mga network outside of our network. Okay. Si switch, ang kausap lang niya, yung LAN lang. Si router, ang kausap niya, different networks. Okay. So, once layer 2 or on PC1 forwards to the default gateway, the router then can start the routing process of getting the information to the actual destination. So, pag PC1, all A's, then source natin is all A's, and the destination natin na MAC will be all 1. Kaya yan. Okay. The data link address is local addressing, so it will have a source and destination for each link. Sabi natin kasi ito part ito at pati itong port na yan, local yan. So local host to host. So source is all A's. PC1 sends the frame. Destination is all 1. R1 default gateway MAC address receives the frame. While L2 local addressing will change from link to link or hop to hop, the L3 addressing remains the same. So whatever, kung pag napunta na siya dito, Okay, pag napunta na siya dito, yung frame na from PC1 napunta kay R1, si R1, titingin, dapat meron dito. Kasi, okay, so si R1 pupunta kay R2. So si R2, ang kanyang destination MAC. So from PC1, which is the source, all A, magiging all 1 na. Okay, all 1 na yan. And ang kanyang destination na ay all 2 na. Okay, ipapasa na niya kay R2 kasi pupunta na yan doon. But the network layer IP address remains the same. Diba? Makikita natin. Dito lang ang nagbabago. So, ibig sabihin, diba, sabi natin, this is one network, this is another network, another network, and then another network. So, pag sinabi niyan, local, LAN, yan, LAN, then LAN, yan, LAN, and then LAN, and then this is another LAN. Okay? So, pag ito lahat, inano nyo, 1 na yan. Diba? Pero per port ng router is part of a certain LAN. So, itong port na to, member ng LAN na to. Itong port na to, member ng LAN na yan. Itong port dito na nilagyan ko ng ganyan, member ng LAN na yan. Itong port na ito, member ng LAN dito. Itong port dito, member ng LAN na yan. So, kaya nga sabi natin is host to host, okay? Or hop to hop. Change from link to link or hop to hop. Okay? So, MAC address nito, pupunta MAC address niyan. Then, palit na. Palit naman. Ito naman yung source, ito naman ang destination. Kasi member sila ng parehong LAN. Okay, tapos pagdating dito kay R2, palit ulit. From ang source ngayon, si R2, papunta na ngayon kay web server. Okay? So data link addresses, since data link address is local addressing, it will have a source and destination for each segment or hop of the journey to the destination. Okay? So the MAC addressing is the first segment. For the first segment is PC1 NIC sense frame. Destination is the first router or the default gateway receives the frame. So ito nga yung sabi natin from original MAC address, yung source, papunta kay router. So ang NIC niya, network card niya, MAC address, network card ng MAC address dito. Okay. So ipapasa niya doon sa kabilang port niya, yung network card dito, and network card nito, another network. Okay, so pagdating dito, ipapasa niya sa kabilang port niya. And then itong network card na to is a member of also ng network na to. So makikita natin na we have ilan? Kulay green na network, kulay gray na network, at kulay blue na network. Okay, so pagdating dito, host to host or hop to hop, yan, host to host, hop to hop, host to host, hop to hop. Okay. So yung una nangyari, kulay green, di ba? Kulay green. From PC1 to router 1. So ito yung kanilang source and destination. But the IP address never changes. Pagdating do sa kabilang side, naging yung source and destination naman yung kulay gray na. Pero yung ating layer T IP packet does not change. Okay? Then, pag nandito na, papasa naman dito sa kabilang side, yung header, layer 2 header natin, itong kulay blue na ang kanyang source and destination na yung server. Okay? So, the MAC addressing for the last segment is source and destination exit interface, sense frame, then the destination or the final destination na natin, in this case, web server NIC receives the frame. Then notice that the packet is not modified, di ba? Itong IP packet natin, but the frame is changing constantly upon changing networks. Therefore, the L3 IP addressing does not change from segment to segment like the L2 MAC addressing. L3 or layer 3 addressing remains the same since it's a global and the ultimate destination is still the web server. Siyempre, ang pag sinabi na yung ultimate, it does not change. Okay? At doon talaga tayo pupunta eh. Pag nagpapalit yan, hindi natin yan mararating. Palit ng palit yung ating ultimate destination. Walang ganun. Okay? So pag sinabi na natin na ultimate destination is a web server with this address, that's the ultimate destination. Okay? So Wireshark, wala tayong Wireshark. Okay. So summary. Okay. Sabi natin that last time, the rules, protocols must have a sender and a receiver, of course, diba? And they have a media in between. Common computer protocols include these requirements: the message encoding. Okay, so for example, yung ating voice from one format to another, or formatting and encapsulation. Okay, so pag nilagay natin from analog, di ba? Analog to digital. Okay, so merong ginagawang encapsulation. Okay, may header, merong trailer. Okay. Size, timing, and delivery option. So, of course, kina-chop-chop natin yan. Anong size? Timing, gaano kabilis yung ating delivery ng bawat segment. And then delivery option. Is it TCP or UDP? Protocols to send the message across the network requires the use of several protocols, di ba? Even though na magsisend lang tayo ng email, maraming protocols na pagdadaanan down the stack. Hindi lang yung Outlook email natin, may SMTP, okay, from the top, SMTP, and then pagdating sa baba, sa lower layers, meron tayong TCP, meron tayong IP, meron tayong MAC addressing, okay, or yung ating ARP. Okay. Yung ARP natin, protocol, diba? Using MAC address. Yung sa IP natin using the routing protocols, and then yung sa ating physical, yung ating zeros and one bits, paano siya dinedetermine, kasi based kung anong media ang gagamitin. Each protocol has its own function, format, and rules of communications. Protocol suites, a protocol suite is a group of interrelated, di ba? Kaya, interrelated, sabi natin, when we send email, we have these interrelated protocols para makarating ang ating email. Ganun din, pag nasend na natin siya, galing sa protocol stack, galing sa baba, pataas, meron din tayong ginagamit na protocol. Okay. TCP/IP protocol suites are the protocols used today. So ito ang common. When we use internet, the TCP/IP protocol suite ang ginagamit natin for interoperability, di ba? Kung merong mga manufactured and they did not include TCP/IP protocol in their network protocol sa isang device, chances are baka hindi yun makakonect sa internet. Or baka hindi talaga makakonect sa internet. Hindi lang baka. Hindi talaga makakonect sa internet dahil wala siyang TCP/IP protocol. Open standards encourage yan. Sabi nga natin, dapat kung gusto mong mag-ride sa internet, gumamit ka ng protocol na mag-interoperate doon sa internet. So, kailangan mo ng TCP/IP. Competition, of course, sabi natin, di ba, pag yung market, marami, and pare-pareho sila ng standard, chances are binababa niya yung price, di ba? Kasi may competition. And then innovation, of course, pag maraming involved na vendors, kanya-kanya silang innovation. Reference model. So there are two models used in networking today, the TCP and the OSI reference model. So the TCP has 4 layers and the OSI has 7 layers. Data encapsulation is the form that a piece of data takes at any layer is called PDU. Okay? After ma-process kasi ng isang layer, may kanya-kanya silang tawag. Ang tawag doon ay Protocol Data Unit. There are 5 different PDUs. Okay. Used in data encapsulation process. From data link, this is from layer 7 to layer 5. Yung ating application, presentation, and session. Segment is the transport layer. Then packet is yung ating network layer. Yung frame is yung ating data link layer, ang product niya yan. And then, yung ating physical layer, yung network bits. Data access, the network and data link layers are going to provide addressing to move data through the network. Layer 3 will provide logical IP addressing and layer 2 will provide permanent or MAC addressing. Okay. The way these layers handle addressing will depend on whether the source and the destination are on the local host or same network, or if the destination is on a different network or remote. Okay. Any question? Any questions sa ating diniscuss? Okay.
Sir, may question lang po ako.
Yes, sige.
Yung dun po sir sa process po nung sa addressing, like, tawag nito, yung ano po, yung pagpasa po ng data, like ano po siya, nag-change po from time to time yung MAC address, pero yung ultimate IP address is same pa rin po.
Yes. Anong question? I-elaborate ko pang konti or anong question mo doon?
Yun nga po sir, tanong ko lang po kung yung MAC address lang po ba talaga yung nag-change and yung IP po is still the same para makarating po dun sa destination.
Okay. Ganito. For example, ikaw pupunta ka ng school. So from your house, 'di ba? From your house, punta ka ng school, sabi natin PUP. So for example, from your house, for example sabihin natin sa Marikina ka. Marikina. From Marikina, kunyari nandun ka sa Marikina Heights. From Marikina Heights, sakay ka ng tricycle, papunta ka ng Concepcion. 'Di ba? Concepcion. So ang network address mo is from your house, this is the source. And then yung destination mo is eto, 'di ba? The school. Pero yung MAC address mo, eto yun, from your house, from Marikina House, papunta Concepcion. So ang source mo ay eto. Ito yung layer 3, ito yung layer 2, ito yung source. Destination mo is layer 2, ayan, Concepcion. From Concepcion, sakay ka na ulit ng jeep. Papunta ka ng Cubao. Ayan. So ang pagdating mo naman sa Concepcion, magpapalit ka ulit ng MAC address. Ng data link address. Kasi ang magiging source mo na ngayon is from Concepcion to Cubao. Parang ganon. So this will be kung wala na yan, so ito na yung magiging source mo na ngayon of layer 2. Ito naman yung destination mo ngayon for layer 2. Pero yung ultimate mo na address or layer 3, hindi naman nagbabago kasi gusto mo pa rin pumunta sa school. Pero nagpapalit ka lang ng mga short distances. 'Di ba? From Cubao, sakay ka ulit ng jeep, punta ka naman ng Teresa, 'di ba? Baba ka doon sa Teresa or Stop and Shop. So from here, pag dumating ka na ng Cubao, tapos na yung destination mo dan, magiging source na 'yan ng layer 2. Ang destination mo ngayon, eto, yung Teresa doon sa sa basketball court. Ito naman nga yung destination mo, layer 2. From Teresa, mag-walk ka na ngayon, papunta sa school. So magiging source na ulit ito, source for layer 2, and destination mo na ito ngayon for layer 2. Layer 2. So ang pumapalit lang diyan yung ito, yung nasa loob. This is the host to host, 'di ba? Host to host. Pero yung ultimate mo, layer 3, yung nasa labas na layer, ayan, layer 3, hindi naman nagbabago, 'di ba? Hindi naman nagbabago. Kaya yan ganyan. Talagang pag nagpapalit lang ng change of hands, parang ganon, nag-change ng hands, yun lang yung nagpapalit. Pero kung saan talaga siya dapat pumunta, hindi nagbabago yung address na yun. Okay? Naintindihan ba?
So parang ano sir, nag-iiba lang po yung medium niya, pero yung pupuntahan po is still the same pa rin po.
Yes, nag-iiba lang siya ng ano, nag-iiba lang siya ng uh, from one device to another device. Kasi 'di ba ang sabi natin, ito ang source, original source mo, ito yung final destination mo. Pero hindi ka naman makakapunta doon directly. Magchi-change ka muna ng isang from this device, punta ka dito sa this device. From this device, punta ka dito sa device na to. From this device, punta ka sa this device na ito. 'Di ba? So yun lang yun. Pero yung ultimate destination mo talaga hindi nagbabago. Okay?
Pero yung ano sir, yung content po nun sir, parang pinapasa lang po talaga, no?
Yes, yes.
Yun lang po talaga
Pag
yun.
inano ko, pag ginanon ko dito, 'di ba? Sabi ko kanina, ito yung unang laman nito, unang laman nitong layer 2, ito yung MAC address nito. Itong dalawa ang unang laman niya. Okay, so ang source mo ito, ang destination mo yan, 'di ba? Ngayon, ito yung packets, pumunta na ngayon sa kanya. Nasa kanya na. Ang next natin, ito namang dalawa magpapalit. So siya ngayon na ang source. Yung source naman ito and then destination na yan. Okay, so pag ito na yung mail natin, pupunta na sa kanya. Ito lang nagpapalit to. Itong portion lang na to. 'Di ba? Itong portion lang. Kagaya dito, ito lang din ang pinalitan natin. Nilagyan natin laman. Pero makikita mo to, hindi na nabago. Hindi na nabago. Okay, ayan. Ayan pa rin. And then next mo, ito naman dalawa. Pero itong layer 3 hindi nagbabago. Okay?
Thank you sir, maliwanag na po.
Okay. Yung iba naintindihan ba any question or clarification? Oops, sorry. Okay. So I think naintindihan naman. Okay. So kasi parang ano yan, nagpapalit ng change of hands from one device to device. Device to device, ang address lang yan is MAC address. Device to device, device to device. Pero yung ito, logical address yan. Hindi yan pag na-determine mo na kung saan ka pupunta, hindi na yan talaga magbabago. Ito na yan, dalawa. Okay. So kung wala ng question, let's continue with our next module. Okay, module 4. Module 4 is our physical layer. Okay, Module 4 is our physical layer. All about yung ating media. So our objective is to explain how physical layer protocol, services, and network media support communications across data networks. Okay, so topic titles include purpose of the physical layer. This is to describe the purpose and functions of the physical layer in the network. Physical layer characteristics. We will describe characteristics of the physical layer. Copper cabling. Identify the basic characteristics of a copper cable. And then UTP cabling. This is the common cable na ginagamit natin when we cable yung ating local area network. Explain how UTP cable is used in the Ethernet network. Then fiber optic cabling describes fiber optic cabling and its main advantages over other media. And of course, yung ating wireless, connecting devices using wired and wireless media. Okay, purpose. Ano ba ang purpose ng ating physical layer? This is used for physical connection. Okay, before any network communication can occur, a physical connection to a local network must be established. Okay, local network pa lang, kailangan meron ka ng physical connection in your local network. This connection could be wired or wireless depending on the setup of your network. So yung selection between a wired and wireless will depend on how you will set up your network. This generally applies whether you are considering a corporate office or you're working at home. A network interface card. Okay, ito yun. Sabi natin, connects a device to the network. This is the interface. Kaya ang interface, di ba? Network interface card. This is the interface to the network. Kung wala kang network interface card, meron kang cable, saan mo yun i-connect? Unless wireless, di ba? Kailangan mo rin ng wireless na network interface card para makakonect ka sa wireless network. Some devices may have just one NIC, while others may have multiple wired and or wireless, for example. Okay. Sa ating laptop, ilan ang network interface card? Anybody know kung ilan ang network interface card ng ating kung isang physical laptop, isang common laptop? Yes, dalawa. Minimum of 2, di ba? Minimum of 2. Okay. Yes, isang wireless at isa yung LAN, yung may cable. Actually, pwede pa ba dagdagan na? Yes. Kasi meron tayong mga USB na Wi-Fi, di ba? USB na Wi-Fi. And meron tayong USB na yes, sir. USB na, yes, dongle. Yan, dongle yun, tinatawag na dongle. Pero meron din USB na cable. Okay. USB rin, pero Ethernet cable ang kinakabit. Okay? Nakita na ba kayo nun? Yung isang side niya USB, yung isang side niya parang malaking ganyan, malaking box na ganyan. Pero ang sinasaksak niya diyan yung cable ng UTP. Okay? So this one is yung dongle. Ito naman, USB rin yung isang side, tapos yung kabilang side, yun yung connection para sa wired. USB din yun. Okay? Bluetooth is considered also as a NIC. Yes, kasi ang ginagamit lang niya is ibang frequency. Kasi wireless din yun. Okay? So, may wireless network like Bluetooth. Okay? Pero ang ibang frequency siya aside from yung ating Wi-Fi talaga na data. So, mas mababang, kaya nga siya mababa yung speed ng transfer and then short distance because they are nasa lower frequency sila. And not like yung ating Wi-Fi, it's either 2.4 gigahertz or at nasa 5 gigahertz. Yan. Eh yung sa Bluetooth naman, mababang ano parang 3 megahertz lang yata yan. Okay. Question, sir, bakit po walang yung ibang laptops walang LAN? Yes, yung ibang laptop lalo na yung mga bagong model. Okay, bagong model, they tend to yes, pinanipisan pa, and then yes, slim type, tapos ang gusto nila kasi is to adapt na doon sa wireless network natin. Kasi yung mga wireless natin bumibilis na eh. Dati kasi ang maximum lang halos ng wireless 10 Mbps. Ngayon meron na tayong mga 110 Mbps. Okay. So might as well, tapos ang gusto pa natin is yung ano ka, accessibility kahit saan ka. So mobility, kahit nasaan kang lugar, connect ka agad without asking any, yes, lalo na yung Wi-Fi 6, lalo na yung gusto mo, pagpunta mo lang sa isang lugar, bigyan ka agad ng SSID password, login ka na. Hindi na yung pengi akong wire ko, connect ko sa switch mo. Hindi, wala nang ganon. Diba? Kaya yung ngayon, puro Wi-Fi na. Kaya rin, as much as possible, wala na yung ating cable, tinatanggal na natin. Diba? Hindi na siya kasama doon. Kaya nga, ano solution doon? Kung gusto mo pa rin mag-cable, bili ka ng ganito, USB to Ethernet cable, USB to Ethernet. So, sigurado naman ako na yung laptop ay hindi pwedeng alisin yung USB ports. Diba? Hindi pwedeng walang USB port yon. Meron yon. So, kung gusto mo pa rin mag-wire, diba? Kasi siyempre, definitely yung wired surpass yung wireless in many ways, diba? Kasi ito is very stable, yung Wi-Fi natin sometimes marami siyang interference. May dadaan lang na tao, o kaya naman nahaharangan yung antena, or na merong mga gadgets na nag-interfere doon sa frequency. So definitely wired network surpasses yung Wi-Fi natin. Okay? Pero kaya nga lang natin yung mga bagong laptops ngayon ay inalis na yung cable kasi nga number one, slim type na sila. Pangalawa, they want to embrace yung Wi-Fi kasi bumilis na rin yung ating Wi-Fi. Pangatlo, syempre ating mobility, di ba? Yan yun. Kaya yan yung speed natin nga ngayon kasi naging Wi-Fi 6 na. Yan. Alam ko mataas pa sa 100 Mbps eh. Baka meron na nga 200 Mbps na Wi-Fi. Baka ito yung Wi-Fi 6 natin. Okay, so depende 'yon sa sa setup ng infrastructure. Kaya nga yan yung pag kayo nasa network, magpo-provide kayo na gusto nyo ang inyong mga client or user ay naka Wi-Fi lahat. Make sure nyo lang din na you're using the highest speed ng Wi-Fi, and then yung pag-place nyo ng inyong mga Wi-Fi device ay tama yung pagkakagamit nyo kasi may mga distance din yan from one device to another, and then yung mga interference kailangan bantayan nyo rin, and then kasi yung mga frequencies din natin, may mga channels din na tinatawag yan. May mga channel 1 hanggang mga channel 7, ganyan. So, later on, pag natin sa Wi-Fi, maintindihan nyo rin yan. Or kung talagang gusto nyo mag-delve sa Wi-Fi, pwede rin. May mga courses din yan, mga Wi-Fi networking or yung ating mga engineering information yan. Kung talagang gusto nyo maging expert sa networking. Okay? Ngayon, nandun muna tayo sa basic. Pero very good na mga question nyo kasi napapansin nyo yung mga actual na scenario. Okay? So, let's continue. This connection could be wire-to-wire depending on the setup of our network. Okay, ito na. Some devices may have just one network interface card while others have yung ating multiple. And ang tawag dyan ay multi Multi-home. Okay. Usually, sino gumagamit yan? Mga multi-home. Mga servers. Okay, mga servers. Usually, mga 2, 3, 4 LAN cards na kasi ang isang LAN card, sabihin natin ay naka 10 gig yung kanyang LAN card na yon. Okay, and then kunyari yung isa 10 gig, pare-parehong 10 gig. 10 gig na LAN card. O apat, sabihin natin 10 gig na LAN card. Apat na 10 gig. And then merong tayong technology sa ating Cisco devices na ang tawag doon na Ether channel. Ether channel. Okay, may command yan sa ating mga switch tsaka router. Ang gagawin niya, pagsasamahin niya tong apat na yan, ang labas niyan 40 gigabits per second na yung speed ng network natin sa isang device. So isang router o sa isang switch, sa switch lang pala Ether channel. Sa isang switch, na 24 port na switch, na ang speed niya, kada port niya is 10 gigabits per second. Kinombine mo yung apat, kaya yung switch mo nagkaroon ng 40 gigabits per second na port. Okay? Because of Ether channel. Okay, Ether channel. Kinombine mo yung apat, then yung apat na yan nagkaroon ng isang IP address, one IP address. As if isang port lang silang lahat. Okay, so Ether channel ang tawag doon. Not all physical connections offer the same level of performance. Okay. Of course, may iba-iba kasing yung speed ng ating di ba? Pati USB, may mga speed din yung. So ang USB na nabili nyo is 2.0, meron ding 3. Yeah. So yung LAN card nyo, bibilis pa yon pag nasa ang USB port nga ay 3. Okay. Physical layer, so transports bits across the network. So ito, bits lang siya. Physical layer. After ng ating Ethernet, yung ating frame data link, magkakaroon na tayo ng synchronization ng bits. So accepts a complete frame from the data link layer and encodes it as series of signals that are transmitted to the local media. This is the last step in the encapsulation process. The next device in the path to the destination receives the bits and re-encapsulate the frame, then decides what to do with it. So after niya makuha itong buong ito na naging frame, ko-convert na yun ngayon sa bits para makadaan dito sa media natin. Okay, again, itong media natin class is lang yan. Kung titingnan natin, isang connection lang, di ba? Isang connection. Pero marami ang gumagamit diyan sa wire na yan. Okay, so pag nakita niyo isang network kasi di ba sabi natin ganyan. Although marami siya naka-connect, diba? Marami yung isang switch, okay, naka-connect sa switch, okay. Pero tas isang server nasa local network. Okay. So kung lahat sila uma-access dito sa server na yan, iisa lang yung wire natin pupunta sa server, ayan lang, di ba? Iyan lang, di ba? So naka-shared din yung device na yan. So imagine na lang kung you have 100 users na na-connect sa network. Tapos meron kang isang server, lahat sila tumatawag doon sa server. So yung 100 users na yan dumadaan sa isang wire na yan, di ba? So yun ang ganun kabilis ang, kung mabilis ang server mo, mabilis ang network device mo, and then yung mga cables na ginagamit mo, mabibilis din. So transparent na yan sa user. Kahit 100 pa ang user mo, sabay-sabay ma-access. Physical layer characteristics. So physical layer standards. So sa physical layer, meron din tayong mga standards body that see to it na they are properly implemented, tapos they are developed. So some of them, the physical standards are implemented in hardware and are governed by many organizations like ISO, EI TIA, ITU-T, ANSI, and IEEE. So the TCP/IP standards are implemented in software and governed by IETF. So pagdating naman dito kasi sa data link layer pataas, halos software-based yan. Kaya ganyan, IETF. Pero pagdating dito sa physical, ano na siya, physical kasi kaya nga physical di ba? So usually mga engineering yung mga ano yan mga standards body na nag-regulate or develop. Okay, so physical layer standards address three functional areas: the physical component, the encoding, and the signaling. So the physical components are the hardware devices, media, and other connectors that transmit the signals that represents the bit. So yun daw, physical component natin are hardware. Of course, physical component devices, the media, and other connectors. So from yung ating network interface card, and then from network interface card, meron siya, bago siya lumabas doon sa cable, meron siyang connector. Okay, may connect ng RJ45, tapos yung female na RJ45 kung saan siya, dahil nandoon yung ating network interface card. So, part din yun ng physical device. Then, yung cable, yung UTP or fiber, part din yun ng ating physical layer. So, yung isa ay encoding. So, encoding converts the stream of bits into a format recognizable by the next device in the network path. So, this coding provides predictable patterns. Okay, dapat talaga predictable. Diba? Para magkaintindihan sila. Huwag yung pabago ba. Kasi pag nadi-distort, yung ating signal, yung coding, yun yung unpredictable. So, chances are, pagdating sa kabilang device, error na yun. Kasi unpredictable. So, examples of encoding methods include Manchester, shown in figure 4B/5B and 8B/10B. Okay, so that's more on engineering na. Kung gusto nyo talagang mag-aral ng kanyang coding na yan. So sabi natin, ito yung volt natin, di ba? If this is 0, if this is 0, and this is 5 volts, plus 5 volts, and this is negative 5 volts. Sa baba, negative 5 volts. Okay, so yan, pag bumaba, pag ang direction kasi, di ba? Sa direction niya, saan ba